Hey guys, hoping all is well with everyone. So in this video, we're going to be looking at the question of the day, and this one is a 7th grade pre-algebra story problem. So the way that this word problem goes is, two friends are at a fruit market. Elena buys one watermelon for $7.65 and 4 pounds of cherries. Tanya buys one pineapple for $2.25 and 3 pounds of cherries. Given P for the value and price for the cost of 1 pound of cherries, create an algebraic expression representing how much more Elena bought than Tanya. Now, I'm going to start things off by talking a little bit about story problems, just on a very brief note. The reason that these become very uneasy and cause a lot of anxiety for students is because the hardest part with these types of questions is translating from the verbal statement into the mathematical operation or expression or equation. So what we're going to do here is we're going to read each sentence and we're going to decipher what is mathematically important and what's more of what I consider the fluff or the filler stuff, the things that just allow you to kind of mentally set up the scenario. So let's go ahead and read sentence by sentence. Two friends are at a fruit market. That's generally okay information. It doesn't tell me too much yet, but it tells me the number of individuals involved and it tells me the place at which it's happening. So far I can't really take too much from it. Elena buys one watermelon for $7.65. I'm going to stop right there because the phrase one watermelon for $7.65 gives me a ratio, or it gives me a unit rate of something that can be very pivotal in the scenario. One watermelon is $7.65. That's pretty helpful. And 4 pounds of cherries. 4 pounds of cherries is helpful even though it doesn't have a price connected to it, because it gives me more information of what she bought. Now I'm going to also throw in this verbal translation of the word and. And is the verbal equivalent of the addition operation. So we can throw in a plus sign there to show its mathematical equivalence. Now let's go to the next part. It says Tanya buys one pineapple for $2.25. Again, that gives me a unit rate or unit price of an object, because Elena only bought one watermelon and Tanya only bought one pineapple. And then we see that and again, very helpful. It means plus 3 pounds of cherries. Okay. Now, at this point, a student may read it and they may again start to get a little uneasy. And the reason is because they've had two scenarios now where there's a certain number of pounds of cherries involved, but they don't know what to do with it, and they're starting to, get a little anxious. But in this next sentence, this is going to bring everything to a more helpful situation. I'm going to use blue here. So it says, given P for the value in price for the cost of 1 pound of cherries. So I'm going to put a box around this P because this is going to be our defined variable. And then I'm going to underline the next part of the sentence because it tells me what P is equal to. It's going to be equal to the price of the cost of 1 pound of cherries. And then the second part of that sentence is to create an algebraic expression representing how much more Elena bought than Tanya. Now, that last part of that sentence doesn't really tell us anything in terms of putting towards our mathematical expressions, but it does tell us exactly what we need to do to solve this problem in terms of the task being creating an algebraic expression. Now, let's go ahead and approach it this way. If we're trying to create an algebraic expression representing how much more Elena bought than Tanya, what we can do is create two individual algebraic expressions using P as the variable in which everything else is relative to, and then subtracting the two algebraic expressions of the individuals, and that will tell us how much more in terms of P Elena bought than Tanya. So let's go ahead and do that. So my first step, so step 1, is going to be create an algebraic expression representing representing the cost for Elena in reference to P. Okay. Perfect. So let's go ahead and review Elena's situation. So that's why in the very beginning it was helpful that we put a box around that watermelon for $7.65, because that tells me that that watermelon costs $7.65. But what's important to understand here is we don't want to add any more variables. This would become a very, very different situation if we put like W for watermelon. But because we know what the price of the watermelon is, we don't have to. So we can say that Elena paid $7.65. Okay. And we also know that the word "and" represents the addition operation. So we can throw that into our expression. 4 pounds of cherries. Now, here's what we know. We know that 1 pound of cherries, or the cost of 1 pound of cherries, can be represented by the variable P. So if Elena bought 4 times as much of that, then we can represent that as 4 times P, or 4P. So that is the individual representation from an algebraic perspective of the cost of Elena's items in reference to P, or 1 pound of cherries. Again, we don't know what the price is of that 1 pound of cherries, and that's okay. This type of question isn't looking for an exact number. It's just asking for an expression relating our two individual cost scenarios. Okay, so step number 2 is going to be, Step number 2 is going to be to create an algebraic expression representing the cost for Tanya in reference to P. Okay, so let's go ahead and do that. I'll use a different color for Tanya. I'll use purple. So for Tanya, she again bought 1 pineapple for $2.25. Now again, we don't want to use another variable to represent the pineapple because we already know what it costs. And we don't want to add multiple variables because again, that would create an entirely different situation. But we can say that she paid at least $2.25. And then we see that plus again, which is going to be that and verbal wording. So we see $2.25 plus, and she bought 3 pounds of cherries. So again, if 1p or p represents the price in the cost for 1 pound of cherries, then we can just multiply that by 3 times that amount, which will be 3p. Now remember, just a couple of insider tips and tricks. Remember, if you are given a variable that doesn't have already a coefficient on it, or a number that is inferred by multiplication on it, you can put a 1 on the variable itself for housekeeping purposes. So again, this is just 4 times 1p, and this is just 3 times 1p. And again, that helps you keep things organized. Alright, now step 3 is going to be to taking the difference of the two expressions. So let's go ahead and do that. And I'm going to still keep the colors to kind of represent how all of these things become subtracted. So this is going to be a subtraction of algebraic expressions. So I'm going to take $7.65 plus 4p minus $2.25 plus 3p. Now, I'm going to state something extremely important here. Because we're subtracting algebraic expressions, it is extremely important that we put parentheses around, at minimal, our second expression. I'm going to explain why in a second, but for good housekeeping and organization, I'm going to put them around both. Now, when we're subtracting algebraic expressions, we are essentially combining like terms. Remember your rules about combining like terms. All constants are always like terms. Constants are terms that do not have any variable associated with them. I personally like to draw arrows between my like terms. So the $7.65 and the $2.25 is a like term. The 4p and the 3p are also like terms because they have the same variable involved and the only variable involved, and that variable goes to the same power. Going forward, you'll learn a little bit more about combining like terms in a little bit more complex of expressions, but having the same exponent or power on the variable is also a rule. I'm going to backtrack 1 second to go back to why I mentioned this is very important. We see this subtraction sign that's right outside this purple parentheses expression. That subtraction sign we're going to treat like we are distributing a -1 as a coefficient into the secondary expression. And the reason for that is because that minus sign is going to force a sign change on all of the terms. Sign changes happen when we multiply or divide by -1. And this minus sign on the outside of the second expression is acting as a coefficient, so we have to use the distribute property to do so. So the first expression is going to stay the same because it doesn't have anything on the outside that's going to change its properties. Okay, now if we do the distribution, -1 times $2.25 is going to be minus $2.25. And then -1 times positive 3p is going to be minus 3p. Now that everything is simplified from that previous step, now I can go back to my combining of my like terms. So again, the constants are all like terms, and the 4p and the minus 3p are also like terms. Now I can determine my final expression by just combining them. So $7, I'll use green here, kind of formulating my final answer. So $7.65 minus $2.25 is $5.40. And then plus 4p minus 3p is just 1p, or if you wanted to keep it a little bit more inferred, you can just say plus p, because it's 1p, but the 1 is inferred. So that is our final answer. That is the expression that is going to represent how much more Elena bought than Tanya in reference to what the price of 1 pound of cherries costs. We know for a fact that outside of the pounds of cherries, that she already has spent $5.40 more, because that's how much more the watermelon cost than the pineapple did. And then she bought 1 more pound's worth of cherries than Tanya did. So that will be our final answer, that the expression that will represent the amount Elena exceeded in reference to Tanya in terms of the unit price of cherries is going to be $5.40 plus p. I hope this helped you guys out, and I know we talked about a lot of different things in relative to translating from the verbal statement to the mathematical equivalent to the two individual expressions. We also talked about how when subtracting those algebraic expressions, we have to be really careful and treat that minus sign on the outside of the second expression like we're distributing a -1, causing the sign change. But if you guys have any questions or any requests for any problems, I'd be more than happy to answer them for you. As always, please take good care of yourselves and be safe, and have a wonderful rest of your day. Bye.